So here we're again given two more geometry problems here. So it's part two here, and again this problem here is quite interesting because what happens is most people think that this is a trapezium, and it's actually not, because when I previously defined a trapezoid, it's a polygon that has exactly one set of parallel lines. Clearly we see three right angles here. This right angle indicates that, again, this is perpendicular to this is perpendicular to this, and this is perpendicular to this, which indirectly alludes to the fact that these two lines are parallel, and these two lines are parallel. Well, if there are two sets of parallel lines, then obviously the entire figure cannot be a trapezium or a trapezoid. However, we can create a trapezium from this figure. So if we look at this carefully, we can draw a dotted line here, and indirectly this gives us a rectangle, and this gives us a trapezium here, because here, if you think about it, this is another line that's being drawn here. This is 90 degrees. Therefore, this line and this line are parallel to each other, and this figure right here has exactly one set of parallel lines. Now to find the area, obviously we can find the area of the rectangle. That's 15 times 10, because it's just length times, or base times height really. And so, sorry, not 15, 15 was the entire segment, so sorry about that, but it's just 5 times 10. So that gives us 50 here. And so we know that the entire thing is 15, right? If the entire thing is 15 and we know that this is 5, this corresponds to this. Therefore, this must be 10. So this part right here must be 10. And we know that this is 10. So obviously this is a rectangle. With a rectangle, opposite sides are of equal length. They're congruent. So this must be 10. We know that this is 10. We know that this is 10. We know that this is given to be 3. And really this is a trapezoid. So if we use the formula base 1 plus base 2 times by the height, all divided by 2, that's the area of a trapezium. And really looking at this, we know base 1's 3, base 2 is 10, that gives us 13, and then we multiply that by the height, which in this case is 10, because it's again perpendicular, here's the right angle, so we multiply that by the height, which is 10, and we divide that outcome by 2, so 130 divided by 2 should give us 65. 65 units square is the answer here. Now looking at the second problem here, it states that the circumference of a circle is 30 pi. Again, we went over circles briefly before, and now again we have to find the area. So looking at this, if we know the formula to find the perimeter or the circumference of a circle is 2 pi r, we can set this equal to 30 pi. Really, pi and pi cancel off, and we get 2r is equal to 30. Therefore, the radius in this case must be 15. Now, if the radius is 15, and we know that to find the area of the circle, that's just pi r squared. Pi r squared is the area. So really, we have the radius, that's 15. We substitute the value in, so we get 225 pi units square is the area of the circle. So again, some basic review problems here. Thanks for watching.